Hi, today I'm going to talk about the material parameter values that you get when you calibrate the material model. I have some experimental data here for an ultra-high molecular weight polyethylene, its uniaxial tension, and some cyclic tension and compression data for this material. I already calibrated a material model, in this case the polyumod 3 network model, to this data. It doesn't really matter for my example which material model I used, but I got a good fit and I use this example here. So what you can see when you run the material model calibration, you get these parameter values that are shown here. The mu A parameter is a shear modulus, and it has a value with all of these significant digits. The question is it really important to have that many significant digits? Is it really all of these relevant in some sense? There is obviously no penalty to using a lot of significant digits in the calibration and then when you export it to finite element simulation. So there is nothing wrong with it, but the question is really how many of these digits are actually providing information here and which of them are more important than others. So I'm going to show you how we can investigate that very quickly using MCalibration. And the way you do it is as you calibrate your material model as you typically do, and you see all of these significant digits here. And then you're going to ask MCalibration to figure out what's really going on with these values. So I'm going to go to click material model and simplify parameters. And then I can specify how much variability I'm allowing here. So I'm going to reduce it by a factor of 10. And I'm going to say OK. What the software will do now is that it will manipulate these parameters a little bit and find out how much it can simplify these values that were given here in order to not, while still not changing the fitness of the calibration. So simplify the parameters, do not allow the calibration get any worse. And the error that we had initially was 10.8 according to this master calibration that I performed. Now we will see in a second how much these parameters can be simplified, which of them can be simplified, and that's going to be an interesting argument, I guess. And particularly, this could be useful if you write papers or if you want to report some of these parameter values, that you don't need to actually specify all of the numbers, digits here. So it took about 10-20 seconds to do this, and now we can see that the parameters can be simplified to these values and still not change the accuracy of the prediction. It's still 10.8. So we can see that the mu A, we had 7 significant digits or so before. Only the first few are important here. So 170 is a value that it's still valid for this material model calibration. And that's kind of interesting. You see how much these parameters can be simplified. We see that beta parameter here, we only need 2 significant digits. Mu BF, on the other hand, needs 4 significant digits. And this is all automatic. It's kind of a fun thing to do when you work with the material model calibration to see which of these parameters can be simplified, how much can the numbers be simplified. And that's very easy to do, as I showed here, using simplified parameters. If you have any questions on this, you can ask them below.